Okay, so you can see by the title today, we're going to be doing some bisecting of an angle, and we're just going to establish a little groundwork too in terms of some more geometry vocabulary. So we're going to kind of start in the middle-ish of our page, like right about here with that second 3-hole punch. And what I want you to do is I just want you to put just a small little point right there in the middle of your paper. And we're going to call that a location in space. And then what we're going to do is we're just going to make a straight path from A out to the side of our paper here. No particular length long. We're just going to go from A out that distance close to the edge of our paper. So just from A out to the edge of our paper there, no particular length. All right, now we're going to take our compass and put our pointer here at point A. And we're going to open it up, I don't know, maybe say like half-ish of that distance. So we got a good size distance to work with here. And then we are going to go ahead and draw a full circle.
Slightly more than half?
Yeah, just about half-ish. You know, you can go a little bit more if you want. We want a nice, clear circle to work with. So we're going to go all the way around. Get a nice full circle. All right. Woo. All right, let's call the intersection of our first line and the circle point B. Okay. Now, what I would like you to do is I would like you to draw angle BAC at 80 degrees. Angle BAC at 80 degrees to the top half of the circle. I want you to draw angle BAC at 80 degrees to the top half of the circle. Let's see what you do. Okay, BAC at 80 degrees to the top half of your circle should have looked like that, right? And again, we can double check it. We line up our protractor and we look at our baseline, make sure it's set, and yeah, I got an 80-degree angle going out there. Okay, you ready? I want you to draw diameter CE. I want you to draw diameter CE. See what you can do. Could have drawn that right there. Now, we're going to talk about in a second here, why that was the only place you could go. We're going to talk about in a second here why that was the only place that you could go. But before we do that, I want you to draw segment CB. I want you to draw segment CB. Go ahead. Pretty straightforward. Segment CB should have looked like that. Right? It's a segment that stretches between points C and B. All right. We're going to take some notes. All right. Segment CB is called a chord, C-H-O-R-D. Segment CB is called a chord, and a chord is a segment that connects 2 points on a circle. So CB in our picture above is called a chord, A chord is a straight path that connects any 2 points on a circle. Now, you'll notice that up here, I asked you to draw diameter CE. But doesn't diameter CE, isn't that a straight path that connects 2 points on a circle? Point C and point E. So really, isn't that a chord by definition? I mean, if the definition of a chord is a straight path that connects any 2 points on a circle, like from C to B, or from C to E, that would make this line that we drew here a chord. And that's actually the definition of a diameter. A diameter is a special type of chord. Just like, again, I've used this example where I could call you all students because you go to school. If I called you Panthers, that's a special type of student. That's a student who attends San Joaquin Memorial. And a diameter is a special type of chord. So let's jot this down. CE is a diameter. And a diameter is a chord that passes through the center of the circle. So the actual definition of a diameter, right? Like you guys is like a diameter, right? Well, I got to draw a line through the circle, right? Through the middle of the circle. Well, yeah, we want to put some geometry language on that. It's a special type of chord. So any straight path that connects 2 points on a circle is called a chord. When that chord passes through the center, it becomes a diameter. When that student attends San Joaquin Memorial, they become a Panther, not just a student. It's a special kind of chord. Okay? It's a more specific name. So just adding to our vocabulary here. All right, now let's talk about some things that we know here. Let's go back up to our picture. What type of a segment is AC? Hint, it's the same type of a segment that's AB. What would we call segment AC? And we could call segment AB the same name. What do you think? What could we call segment AC and AB? What title could we give them that's the same? Yeah, they're radiuses, right? They are lines that go from the center of the circle and intersect a point on the circle. And what we know about circles is all radiuses have the same length, right? So we could put a congruence mark here and a congruence mark here. Is everybody okay with that? That makes reasonable sense, yeah? Okay. What kind of a triangle is triangle CAB?
Isosceles acute. Or acute isosceles.
Okay, good. Yeah, so it's an acute, because this is clearly, we made it 80 degrees, right? It's going to be less than that. Do we know the measure of angle BAC? Or I'm sorry, BCA? Do we know the measure of angle BCA?
Yeah.
Without measuring it, could we figure it out? What is it? How's it 50, Jackson?
Because it adds up to what he says.
What he said? You're going to go with what Max said?
Yeah.
Go ahead. Why don't you give it a try?
Because 50 plus 50 equals 100 and 100 plus 80 equals 180.
Good, right? So yeah, this is what we were working on the other day, right? Yeah. So we know that angle BCA and angle CBA are congruent, right? And so the other day, what I had asked you to do, we'll put some congruency arcs on there. The other day, what I had asked you to do was I had asked you to create another set of triangles so we could test out our triangle angle sum theorem. And I had asked you to bisect that non-congruent side of the isosceles triangle. Okay? And what we discovered happened was that in bisecting that side, we ended up bisecting the angle at the top of the triangle as well. So let's do that same thing again, right? And let's see if we can't take this and apply it into sort of a bigger perspective. So let's bisect segment CB. So I want you to bisect segment CB with your construction tool. Ready? Go. Okay, then you should have had this on your paper here, and we're going to call that intersection with our circle D. Okay, so now, what is the measure of angle CAD? CAD. What do you think the measure of angle CAD is? Should be. CAD. From C to A out to D. This space in here. CAD. What should that be? Why 40? Yeah, because we started with an 80-degree angle, right? And what we saw the other day was it bisected that angle. And so let's check it and see. I'm going to line my vertex up on this one here like that. And look at that. I got myself a 40-degree angle. Okay, so this is 40 degrees and this is 40 degrees. Cool. Okay, let's kind of put this whole thing together and see if we can't develop a system for bisecting any angle that we want. Without having to go through all of this, let's kind of talk about what made this possible for a second, okay? What made this possible, first off, was that we had an isosceles triangle. What made this possible was that we had an isosceles triangle. And that came from radiuses or equal measurements along the sides of our angles. You with me so far? Okay. And once we knew where those equal measurements were, we knew that this was exactly distance, which makes this distance. I don't even know what the numbers are. You know, they're the same, whatever they are, because they're radiuses. Once I knew that those distances were the same, then we were able to draw a line in between them, bisect that line, and that would bisect the angle. Because these distances are the same. Because it's an isosceles triangle. Does that make sense? Okay. So now let's take that and see if we can sort of apply it kind of more generically. So let's go to the back side of our paper here. All right, back side of our paper. Let's just start. I'll zoom out just a little bit. Let's just start with our ruler on our paper, kind of going downwards-ish, like this. Okay, so we're going to just start with our ruler, going downwards-ish, like this, and we're just going to draw a straight path. No particular length, just drawing a straight path.
Like in any direction?
Okay, well, you know, this-ish direction, so yours kind of looks like mine. Okay? And we're going to call this, again, A out here. So what I want you to do is I want you to draw a 50-degree angle from point A going back to the top of your paper. And when you draw the line, make it about the same length as this. Okay? 50-degree angle going back towards the top of your paper at vertex A. Make it about the same length as that line there. Go ahead. 50-degree angle going back towards the top of your paper should have looked something like that. And again, we could check it, right, by lining our protractor up along our side here. And right out the 50 line. All right, now. Let's focus it up a little bit. All right, here we go. So we're going to pick a compass setting. I don't know. Let's go here-ish. We're going to pick a compass setting in this place-ish out here. It's ish. let's pick a compass setting here. And here's what we're going to do. We're just going to put a little mark on our line here, like that. And keeping that same compass setting, I'm just going to come up to the other side of my angle, and I'm just going to put a little mark like that. Now, keep in mind, this could be a whole circle, right? I could draw a whole circle through here. But I really don't need all of that. And I want to try to keep my constructions clean. So I'm just going to put a little mark here and a little mark here. But I want you to see something really clearly. And it's easier to see when you're not distracted talking about something else. Okay. This is a radius of what could have been that circle. This is also a radius of what could have been that circle. So that means we have equidistances along the sides of our angles. So we could connect a point from here to here, a line segment, and we would have a chord. We're not going to do that, but we could. And that would be just like what we did here. I want you to see the connection between what I'm doing, okay? This is just the little arc here, just the little arc here. I could draw a line segment in between those two arcs, and I would have a chord, yeah? So see that here, little arc here, little arc here. Could have been a big circle, could draw a line segment between here, but I don't need to because I already know what's going to happen. And if I bisect this imaginary line that goes between here, well, how would I do that? Well, I would start at one end of my line segment, and I would make sure that I'm open more than halfway to my other end of my line segment. And here, check this out. You remember the whole thing with the point off the line where we only needed one set of arcs because we knew the other point was on the line? Well, now we know that point A is going to be bisected. It's going to be on our line when we bisect this imaginary line here. So really, I only need one set of crossing arcs. And so I'm going to start here, and I'm going to come out into my angle space out here, and I'm just going to make an arc out here in my angle space. And then I'm going to come to the other side of my imaginary line segment, and I'm going to make an arc out here in my angle space. Because keep in mind, what I'm doing is I'm bisecting this imaginary line by going more than halfway and arcing. And since I have 2 points now that I know are on that line segment, I can connect this intersection with point A. Get my ruler where I want it to be. And what I should have been able to do was bisect my angle. What was the degree that we started with? 50. So then that should make both sides of this angle 25. So then I can come up here and I can line up my baseline and my vertex. And look at that. Right in between the 20 and the 30. And I could even check this one here just to double check and make sure I did that right. Line up my baseline right in between the 20 and the 30. Okay, bisecting an angle. I'm going to review the steps with you, and then I'm going to trust that you know how to do it. So let's go over one more time what I did. I started with an angle. I set my compass setting to some non-defined setting, and I put an arc through one side of my angle and an arc through the other side of my angle. And it doesn't really matter what that setting is, because as long as this distance matches this distance, if I were to connect those 2 points with a straight path, I'd have an isosceles triangle. And so I'm going to pretend that I have a straight path here, not actually going to draw it, but I'm going to do the construction like I'm bisecting that pretend chord. And I'm just going to go more than halfway And then I only need one set of arcs out here from both sides because I can connect that intersection back to my original vertice because I know that that's going to bisect it because of the study we did on the front side of our paper. How to bisect an angle. You got it? Any questions on that? Okay then. Let's make some notes at the bottom of our paper because this is an important concept to understand right here. The shortest distance between a point and a segment is a perpendicular line. The shortest distance, I'm going to underline these things, between a point and a segment is a perpendicular line. What does it mean for lines to be perpendicular? What does it mean for lines to be perpendicular?
To intersect at 90 degrees.
Yeah, to intersect at 90 degrees. So the shortest distance between a point in space and a line segment is a perpendicular line. Okay. All right. So then here's what I'd like you to do. Okay. So we're going to put a point, and I'm just going to do a little hash mark through there, about there-ish, on my bisector line. And I'm going to call that point B. Okay. What I want you to do is I want you to drop a perpendicular line to both sides of the angle from point B. I want you to drop perpendicular lines to both sides of the angle from point B. Ready? Go. There you go. There you go. There you All right. So I'm just going to make sure that we're clear on the instructions.